question 11. 11.1, we are told that event A and B are independent events, and probability of A is equals to 0.4, probability of B is equals to 0.25. So 11.1.1 represent the information given on the on a Venn diagram. Indicate on the Venn diagram the probabilities associated with each region. So drawing the Venn diagram is gonna look like this, right? And we will have A here. Let me just represent with a different color. So this would be A, and then this would be B, right? So the probability of A, if we were to write probability of A, we can't just write probability of A inside the box here, right? Because finding the probability of A and B is equals to 0.4 times 0.25. The intersection is equals to 0.1. So meaning here in the middle, I just don't have space. Let me just write here. So we have the probability of A being equals to 0.4, probability of B being equals to 0.25, and probability of A and B is equals to 0.4 times 0.25, right, which is equal to 0.1. And representing this in our diagram, right, so we're gonna have first probability, and then the second one like that, and then this would be A, this would be B, and then the intersection is 0.1, so meaning here it's 0.1, and the probability of A would be, finding the probability of A and writing it here would be equals to 0.4 minus 0.1, which is 0.3, right? So you're going to write 0.3 here, and then the probability of B in this diagram would be the given 0.25 minus 0.1, right? Which is 0.15. So 0.15, and then we want the probability of not A and not B, right? So how we do that is by saying probability of not A and not B, right? So how we can get this probability is by saying 1 minus the union, right? The union, I mean both A and B. So it's going to be 0.4, which is just a combination of the intersection, but let me just write everything. 0.3, which is this one here, plus 0.1, which is this one here, right? And 0.15, right? So you're just gonna add all and subtract from 1, and you should get 0.45. So meaning here it's gonna be 0.45. Then yeah, we're done for this. And then 11.1.2 says that determine the probability of A not B. So you're just gonna say 1 minus probability of not B, right? So what you're gonna do is probability of not B is actually probability of B. So 1 minus probability of B to find the probability of A not B, which is equals to 1 minus probability of B we found to be this one here, right? 0.15, right, excluding the intersection, so it's going to be 0.15, so we'll get 0.85. So the reason why I didn't include the 0.1, or I didn't write the 0.25, because that's the probability of B, is because we want to exclude A, right? Or we just want to consider B only without A, so that we get not B. So yeah, this is the answer for this question here. And then let me erase here. So 11.2 says that Motors Incorporated manufacture cars with 5 different body styles, 4 different interior colors, and 6 different exterior colors as indicated. So these are the 5 body styles, and all of these are the interior colors, and these are the exterior colors, right? So there are 5, and here it's 1, 2, 3, 4, so there are 4. Here it's 1, 2, 3, 4, 5, 6. There's 6 in total. Cool. So the interior color of the car must not be the same as the exterior. So you can't be having blue in the interior and also blue in the exterior. So you need to choose another color. So Motor Incorporated wants to display one of each possible variations on its car in their showroom. Excuse me, the showroom has a floor space of 500 square meter, and each car requires a floor space of 5 square meter. Is this possible? So what we're gonna do here is we're just gonna say we're having 5. Now we're choosing, right? We're just gonna choose each style or each color for just one car, and but we're just gonna do that for all the 5 body styles, or let me just say all the 5 cars, right? So what's gonna happen is this: we will have we have 5 body styles. So if we begin by saying we have 5 body styles and we choose one color here, let's say we choose blue. So we're gonna choose that one color, and then we can't choose blue here now at the exterior color, so we can choose silver, right? And when we choose silver, how many colors do we have left? We have 1, 2, 3, 4, 5. So there's only 5 colors left, right? So that is the first option. And another option would be to choose all 5 body styles. Let me just erase this. Choose the 5 body styles. Now we choose gray, and we choose any color. We can choose silver if we want. And how many would we have left? We would be 5, right? So but it doesn't really matter now, because we have actually all the options now. Since there's no gray in this side, we have all the options to choose from. So we have all 6 options. So here we have one color to choose, and here it's just 5 body styles. So it's going to be 5 body styles multiplied by one color multiplied by all 6 options, and then plus into all 5 body styles and the black, right? And so there's no black here, so we have all the options, which are 6. So it's 5 times 1 times 6, right? And then we have all body styles, and now we want red, and we cannot choose this red. So how many options do we have? It's 1, 2, 3, 4, 5. So we have 5 options. So it's going to be 5 body styles times 1 times 5. So we're just going to add all these, right? So it's going to be this one here, which is 25, plus this, which is 30, plus this, which is 30, plus this, which is 25. So when you add them together, you should get 110, right? So once we have that, we want each car holds 5 square meter, right? And we have 110 multiplied by 5 should give us 550. So this space that is required is 500 square meter, of which our 550 is greater than 500 square meter. So therefore there's not enough space, right? So yeah, that's how we solve this problem here, and we are done.
Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.